Mm. Well, that took some drama. Let me tell you. Oh my gosh, guys. I apologize so much for that. That is probably some of the most drama that I have seen in a while. It was bugging out really bad, guys, until I refreshed it, rebooted the computer, deleted my old stream off YouTube, and here I am. It finally worked. That's amazing. Needless to say, the live stream capabilities of YouTube is probably one of the buggiest pieces of software I've ever used. And when you get it to interface with a streaming software, oh, it gets way buggier. So thank you guys for showing up, man. It proved that this is working. I decided to get rid of OBS. Gone, because what a pain that was. And now I'm just using straight off YouTube. So I have one camera angle, which is okay because this one is actually a pretty good camera. And Steve, man, you missed all the errors that I had on my stream, man. I've been fighting this computer for a little bit, but this is a zero lag live stream, so it's way better than what I've done the last couple times, and that's good because I have so much stuff that I want to show you guys. I was cleaning out a back room, which is a storage area, and I pulled out some stuff that's like some serious history. All right, and I thought this is going to be so cool. I want to show you guys, and I want to pull this stuff apart because this stuff right here is you know, it's my career in a nutshell, you know, some of this stuff. But let's go ahead and take a look, man. First off, some of you biomeds might realize what this guy is. This is a 3-channel infusion pump, Med System 3. This right here is some history. I completely forgot about these pumps, and I can't believe I forgot about these pumps because we all worked on these things diligently for over a decade. I mean, these things right here, all biomeds know what these pumps are, and they all know about the pains in the ass that these pumps were. So for those of you that don't know, this is a battery-powered pump, which this won't even turn on. It's been sitting for a long time. If this turns on, it'll be a miracle. No, of course not. Oh well. Maybe I'll hook it up to a DC external power supply. See if I can get it up and going. The Med System 3. There's 3 little cassettes that popped in here, and got these tiny, tiny little arms that did the pumping. And this pump right here would give so many different errors. I mean, this stream is going to be watched by hundreds of other people, and a lot of them are going to be biomeds, and I hope they all remember all the little pains that we had going through these pumps compared to the pumps that we use nowadays, which are generally pretty much alarm free. Like the Alaris pumps they have a fraction of the amount of alarms that this guy did. So let's go ahead and take a look at it, because this brings back a lot of memories, guys. Oh my goodness, look at this beautiful pump. So you can see right here the 3 different channels. And let's hold on. Let me see if I can get some light on this situation. I'll take off the light off my microscope. I finally got my workbench set up properly. Okay, so there you can see up inside. Let me get my pointer. Okay, so you have your pumping mechanism, which goes up and down. You got right here this little foot. We have a ultrasonic sensor, which is in between these 2 right here. There is a pressure sensor, which is this disc right up here. And then this guy right here actuates valves. Those 2 little fingers will actually actuate the valve. Oh yeah, those pressure sensors, I remember changing those out. I remember changing out the motor assemblies. It's been years since I pulled one of these apart. Years and years. It's probably been shoot, it's definitely been close to 10 years. So I'm going to go ahead and pull this guy apart and see if I remember how to do it. Screen quality is a bit blurry. You're blurry, man. Stop. Hold on. Let me see if I can adjust the stream. Oh, still bugging out. I love it. It's bugging out. Guys, I have nothing nice to say about YouTube right now. I really don't. I really don't. Let's see. Let's see if I can do something about the quality. Cancel. All right. Well, hopefully the quality stays good, because otherwise I got to get another PC, and that's not going to be good. So anyway, let me pull off the bottom cap. I do remember that it's been absolutely years since I pulled this apart. So you can see right here the pumping mechanism, and this right here is a sensor assembly. So you get your ultrasonic sensor, and you got a pressure sensor, that disc up in there. Let's go ahead and take the battery off it. So if I don't take this apart in the right order, you guys are going to have to forgive me. It's been a long, long time since I've had to do this. Do any of you guys still have these pumps in your facilities? Can you even still get the consumables for these pumps? I would really like to know. This is kind of crazy. Oh my goodness, yes. All right, so the battery pack, this disconnector. Oh wow, okay. So the batteries are still intact after all these years of being in storage. Oh wow, this battery was just changed in 2017. I'm extremely surprised about that. Life Flight, you got those in Life Flight, huh? I'm surprised about that. Okay, let's see what we got. I remember. Let's pull off the bottom assembly. I'm just going to pull this all apart. So I know I'm not pulling out the Allens. That's okay. I'm just going to pull it all apart so that everybody can see how many pieces there really are to these. Right. Let's get the Allen. This one. Ha. First try. So this should slide out the motor assemblies. Notice how there's O-rings on every single plate. Let's see, what am I being caught on? Okay, all right. It's news to me. Okay, so there's 3 different things that I've got to disconnect. One of them is this ribbon cable right here. All right. One of them is this cable right here. Wow, this one here looks like it's been damaged previously. Sorry, guys, I'm not getting you in the frame. Come on. Oh, I remember hating these things. I hate these things. There we go. All right. All right. So there was a wide ribbon cable, which is for your I/O ports. There is an encoder, or not an encoder, but this here is for all your membrane buttons on the front. And this other one right here is, I believe, for the power to your external power right here, and maybe your comms. It's almost definitely the power though. So there we go. And this one here is for your battery input. Wow, look at this. It's nice to see, you know, one of these units without a broken screen because I've seen many broken screens on these guys over the years. Oh, wow. Look at this. So the internal lithium battery, February of 2017. Whoop, I'm going to erase it. Oh, well. Okay. Let's separate this bad boy out. All right. There we go. I'm trying not to break it because I'm going to put it back together as soon as the stream is done. Let's take the display off. Right. There we go. So that was the video connector, and what's this? Is this the power connector for it? Power and video. Kind of cool, all in one card. I remember doing depot level repairs on these guys, and we would have these parts in bins, just all sorts of them. All right, now we got in the meat and taters of it. You see the tiny little motors. These are little Swiss-made motors. These remind me of the same type of motors that we see on linear actuators and some other really expensive medical devices. Swiss-made motors. There's an eccentric cam, which creates the pumping action. I'll pull it apart. I'll let you all see it. But yeah, these ones are way more complex than some of the newer ones. Let's see. Oh, which one is it? Gosh, I remember back in the day we used to have all these like screwdrivers already set out on like a magnetic strip, just ready to go. Nope, not that one. It's a good thing I got all these screwdrivers though. Could you imagine like tearing apart something like this without having all your drivers lined up and ready? There we go. This one's coming out way tougher. What's going on? All right, there's a standoff and it's threading or de-threading from another board. All right. You can see the ground jumper. There's nothing I can really do about that at the moment. This is that I/O, the incoming power. That's what a power distribution board, I guess. That's what you can call it. There is a very unique fuse right here. See this guy? It's like a canister fuse. Haven't seen one of those before. Yeah, if I remember right, these guys are certified. They're air certified to be used in airplanes. What is this? Is this an old AMD chip? It sure is. Here, let me see if I can get that up nice and close. Come on. These cameras are so fussy on working distance. Anyway, this is who's this one? AM27C020, 1988 AMD. Oh, come on, camera. Anyway, it's interesting that the processor was put on just as a daughter card, you know. That was very interesting. So the processor just slides on. I guess it's an easy path of upgrade, or maybe there was common problems with the older chips. I don't know. I guess you could swap out the software version. It's got a software version written on the chip, I think. I don't know, guys. You bought a quick TS1200A, Steve. Man, I hope you get some extra tips for it. I got mine right here. So I just plugged mine in. I've got a chisel tip, which you can see right there. And I got a conical, or the factory J hook tip, which is right here. And those ones are for special purposes, because for most of all the things I do, I use this one right here. See it? I do so much with this one, it's not even funny. I just did I was gonna record it. I had a toy kids microphone, which actually had a pretty complex circuit inside it. But I had a cracked solder joint at the power button, because the flashing around the power button meant that you had to push extra hard on it. And because the kids were doing that, they broke it at the circuit board. So I had to restore the traces using strands of copper from like a 22 gauge cable like this. So anyway, one tiny strand, you solder it in place, and I use this big old tip to do it. And one of the good things about this tip is that this one here, there it goes. This tip right here has a large flat surface which likes to collect solder. So it makes it very easy to tap on a piece of solder, melt it down, and you have a bubble there ready to melt a couple wires together. Only thing is, your precision is definitely not so good because it's a larger tip, but this guy can handle some heat. And that's what I really like about it, is if you have a larger solder mass, which there's none on this guy, but if I had to desolder something, this one right here is extremely, extremely nice. And also, when I bought mine, I did not know that when you grip the iron, like there's a sensor in here, and when you grip it, it wakes it up when it's in sleep mode. So you pick it up, and as soon as you grip it, it senses it, and it wakes up the iron. And it is up to temperature in what, 4 or 5 seconds, maybe, something like that. But yeah, that's an excellent, excellent iron, man. And I also recommend the quick 861DW hot air station. I've got mine right over here. See how I got my hot air station set up right next to my soldering iron? Whoop. And then under that's my desoldering tool, which I really don't use anymore. Maybe if I had something large, but most of the things I prefer solder wick. But Bjorn, I think you are absolutely right about the UV light, and is that an EEPROM? Yes, there is a window. Well, that is some old school shit right there, man. Yep, it is EEPROM. I didn't even feel the sticker. All right, let's see. I have got. Well, that's interesting. I'll have to fix that guy later. This one here has got resistors and capacitors, and they're lined up on different pins. I wonder if that is a voltage divider for setting speeds or something. I don't know. That's a weird little card. Seems like a lot of added expense, whereas nowadays, you know, it would be surface mount, and this would be a fraction of the size. It'd be crazy small. All right, let's take these motors off, man. Let's see. Hold on. All right, guys. Hey, just bringing it up. Do you guys know that the MD Expo is coming up in Dallas in April? If you didn't know, I'm going to be there. I'm going to be wearing a shirt like this with my logo on it. There's a couple company booths. They've asked me to stop by and chit chat with them, hang out. So I'm going to be floating around the MD Expo up in April 16th and 17th. It's going to be a real cool time. I can't wait. I think a lot of us have been kind of itching to get out and to go and meet some of our peers, go and do some stuff. And it's just going to be an excellent opportunity, man. So if you guys are going to be there, look for me. It'd be nice to meet some of you guys in person. All right, so these guys right here, they have really fine ribbon cables. And this is such a cool tool right here, this WeHa. So I use this for so much stuff. I use it for pin straightening. You're going to see right now, I use it for undoing a lot of ribbon cables. There we go. Come on. Here we go. Last one. All right. Very cool. Let's pull this card off and see the motors in all their glory. Actually, I might use these motors for another project. Let's see. They're extremely powerful, these little bastards. All right. So you can see how I use this to get underneath jumper wires so that I pull them out nice and even. Because you know how it is, you'll be pulling from one side and you know it'll cant on the pins and it'll start bending some of the other pins. So with this guy, I can kind of get underneath the jumper or underneath the connector and I can pull it out. So that works out pretty well. Okay. Man, I wish I had the rest of my tools unpacked because I have tweezers and stuff that would have greatly assisted me right now. What did I just do with them? I just had a set of tweezers on my desk moments ago, and I wish I had them right now. Oh, where are you? Here we go. All right. Excellent. There we go. Much, much better. My fat fingers don't work so well getting down in between all these wires. Come on. There it is. There it is. Wow. Man, I do remember this being a pain in the ass. And it is not letting me down. All right. Fat ribbon cable. Right. Cool. Look at that. This seems like a very overbuilt product, but considering when it came out and the size of it, it's actually pretty nifty, man. Pretty darn nifty. So look at how complex this board is. And that is your motor driver board, your sensor board, I mean, it's got a little bit of everything going on there. Put that guy down. I'm trying to look for dates on some of these things. I think 1994. I'm seeing some 94s on some of the stuff. Wow, that's back a long time. So I started as a biomed in 2003. So a lot of this stuff was definitely in full circulation when I was a junior level biomed. Okay, let's pull some of these motor assemblies off so that y'all can see them. So these motors, there's 3 of them. It's a whole entire assembly. And what I do remember is that you can flip-flop them in between. You know, they don't necessarily have to be all the way to the left or all the way to the right or the middle. They're all the same. There we go. All right, so hopefully you guys can see what's going on here. I've got, well, here's obviously my motor drive wires. And this one here is controlling a set of micro switches, which there's a, let's see, can I show it to you guys? There is a rotating disc right here, and I see a whole bunch of grooves cut into it. So that means that there's an optical sensor up in here, and what it does is it's an optical interrupter. So that's how it counts its revolutions and its speed. It also looks like it has a couple reeds in there that will open and close a circuit. Yeah, it does. Anyway, one of the biggest flaws of this motor assembly, you can see right here, it has a rubber drive band. You see that right here? A rubber drive band. So I'm going to go ahead and pull it off. So it's just a regular O-ring, and I remember we used to have to change these damn things out all the time. And then that turns this guy right here, which is your cam. See that? And this cam would have the foot right here. See that? So this right here is your journal. It rides in the groove, spring-loaded foot, and that's your pumping mechanism. So I don't remember what the flow rate is on this guy, but I remember that this guy could get cranking pretty quick. Right here's your pressure sensor. You can see right here from the top view. From the bottom view, it's just a pressure disc. Let's see. There, you can see it, pressure disc. And these guys, let's see. These guys right here, see these ones right here? Those ones there operate valves on the consumable, and those ride on this cam right here, on this face. Right? So this face is doing something, and this groove right here is doing something. See that? Seems a little over-engineered, I'm sure. Is this still messing up, guys? My video's still messing up? Oh, that just drives me crazy. That drives me absolutely crazy. I hope the audio's still coming through. Hold on, let me see if I can clean this up a little bit. So that, guys, is the 3-channel pump, and it's a very overbuilt device, in my opinion. You can see we still have through-hole componentry. We have some surface mount. Just a little bit of everything, man. Is what it is. Let's bring back a lot of memories. Sorry if I'm sitting here looking at this like a goofball, but wow, I remember changing out probably 100+ of these pump motors, man. And these things were not cheap. Anyway, those are cool little project motors. I dig that. Maybe I'll come up with something for this. Let's get on the next thing, man, because I have lots of stuff to go through. All right, here we go. So this is definitely some old school stuff. Have a 7. Hundreds of these, man. All right. Okay. Oh, let's see this guy. I don't even know why we kept some of this stuff around. Why did we keep all this garbage around, man? I keep talking about like the baby boomer mentality is to like keep stuff forever, and this is all part of it, man. This is an old school camera from inside an operating room light. All right. So what happens is there's a sterile plastic sleeve that fits over this, and that allows the surgeon to grab onto the light and move it around to wherever they want to go. And this camera records what they need to do. And the thing is, the old cameras are all analog. Every single one of these are analog. So that means that this is less than VGA quality. This is all composite. All right, guaranteed this is composite video, unless this is a super high-end camera. But this one comes out of a Steris light head, and let's see if I can take this bad boy apart, because this was probably a crazy expensive camera back in the day. And it's all just kind of shoved into this camera head. And I think they take aftermarket cameras and they strip them down to get them to fit inside these light heads. So let's take a look and see if I can do that. So this is Steris, and Steris back in the day was a very, very reliable company. And I imagine that this guy's overbuilt, just a lot like that pump that I just took apart. So one of the things that I can see right away is there's this ring. Oh, shoot. I miss having 2 camera angles. There's a ring right here. You can see it fits in this groove. There we go. Wow, this ring goes around like twice. This camera was never going to come out of here without a lot of love. There we go. Jeez. All right. There we go. Shoot. Take a look at that. So that's the sleeve to the light head. You can tell by the color how old this thing is. We're going to see if we can read on one of these boards, maybe a production date. Oh, wow. There's more going on with this than y'all think, man. I see right here, it looks like a planetary motor. So is that for focus or for rotation? It looks like it's set for rotation. Okay, well, we're going to pull it all apart, man. Hell yeah. Let's do it. Let's see. This is an interesting era of technology, because there's a lot of this stuff at this time that was still standard. It's not metric. Whereas nowadays, a lot of this stuff has evolved into metric, because Europe is where a good share of medical equipment is manufactured. There we go. Wow. That's tight. Oh my gosh. It's like bending my screwdrivers that was in there so well. One of the things I really like about older equipment is the quality of the machining, like the surface, the details, the minute details. Like I can see the machining on this guy, how they chamfered the aluminum. Man, they just used to do such a good job. You don't see a lot of that in modern day medical equipment, unless it comes from, Germany. Anything with the name of like Zeiss on it will be really well made and very expensive. There we go. I have a feeling that some of these connectors are getting a little brittle with age. There we go. All right. All right. I was trying to be somewhat gingerly, but not. Okay, so I can see this is the rotator. And it's got another one of those rings that we can pop out. So let's do that. Wow, that's going to be so tough without migrating that motor. Oh, geez, guys. I don't know. I might have to do this one another day. There it goes. There it goes. I just had to show it enough love. So there's the ring. Oh my gosh. Okay, so it's not a planetary. Well, yeah, it kind of is. How do I get that apart? All right. Wow, you can hear how stuck those things are, man. That's probably what, 20 years at least that those things have been on there. Looks like a fuel pump. Yeah, this guy. This is actually such a well-made part. The reason that they're probably keeping this thing around is because I still have some light heads that use these, but maybe it's just me. We shouldn't keep some of this garbage around because, yes, if we have a failure in the room, they're going to be down, but sometimes it takes those critical downs for them to advance their initiative for getting rid of old medical equipment. We have this phrase called sometimes it's got to fail. Let it fail. And sometimes it has to fail in order for hospitals to get the hint that, hey, they need to like upgrade their surgical suites, or they've got to, I don't really care, guys. I'm going to just break this because it's a little pain in the butt. Yeah, hospitals can be so strict on money, and then they'll waste money on something so stupid. Like a doctor will come in and he will want some stupid robot, and then I've seen the doctor leave just maybe 6 months to a year after he gets his $100,000 robot. It's, oh my gosh, guys. I've seen some real wasteful attitudes when it comes to medical equipment. But, oh, look at this. So here's something that I didn't even take notice on. This little guy right here is the motor, the drive motor for the rotator. You see that? And of course, it's a Swiss-made motor. A lot of motors, a lot of these fine detail motors, like some of them that we used in linear accelerators and X-ray equipment and stuff, a lot of these little cylindrical motors are Swiss-made. They're just obviously some of the best. Let me pull this guy completely apart. This little motor right here, this is a win. I'm going to keep him. Let me clip these wires. There we go. Okay. I don't really care because this guy is obviously not going back into service. I'll probably get somebody writing me about how I shouldn't be destroying equipment. It happens, man. Okay, so there's one set screw holding the motor in. Let's see if I can get it out with this guy. More. Holy cow, that's tiny. And of course, it's got Loctite on it. There we go. No, it's no Loctite. It's just a precision fit. All right, look at that guy. And I do have a DC power supply here, regulated DC power supply, so I could give this guy, give it a gopher. So that's the motor right there, and that right there is the gear reduction. Look at this. That's got a steep gear reduction. Maybe the camera for the next live stream. You are not shitting me. I've got hundreds of dollars in cameras right here. But when it comes to a video stream, you know what I got to do? I got to dig a ditch between my garage and over to the far side of my house, and I have to bury a cable so that I can have a cable stream. Because doing it over Wi-Fi, I'll tell you right now, like I have elementary school right in my house, and there's so much traffic on the Wi-Fi. You know, all the channels that I have to choose from for running the Wi-Fi. It's very noisy electrically. This entire area. Wow, look at this. Flathead screws. Let's go ahead and pull some of these out. Pull this mounting plate off so that we can see the underside of the camera. So if this camera isn't VGA, then it's almost certainly a composite video. Pretty much everything from this era was. And they used to run composite through not an RCA jack, but through a BNC. Yeah, they used to run composite video through coax cable in a lot of these older operating rooms. All right, man, I went from a small motor to an even smaller motor right there. Okay. Well, that is the camera in a nutshell, man. I'm looking for a date, something I can use to figure out how old this guy is. $1992. Looks like it's 1992, guys. So it's almost definitely composite. So, yep. They take a security camera, more than likely, something like that, and they strip it of all its outer beauty, and then they cram it inside one of these. And that used to be how they would do a lot of medical devices. They would do one-offs. So that's a cool little device. And this would be a, well, this technically would be a Planet gear system. It's not a gear reduction, but you see what it is. It has a ring gear, and it rode on the outside, rotated the camera. So when I tear stuff apart, I love saving stuff like that. Never know when I'm going to use it. What a cool little feature. With a gear reduction. So I bet you that guy right there is very strong. And some spare parts. The machining finish is very nice up in there. Very nice. All machined out. Very cool. Oh yeah, right there's a bearing. It's got a fiberglass bearing. It looks like it's fiberglass. And that's what it rode on when it rotated. Let's see. Let me clear off my desk because I have a couple other things, and I got a big thing over here that I want to share with all you guys. I got to put all these parts. Why not? In the box. Guys, if you ever take this stuff apart and you have a bunch of extra fasteners like these little guys, all good biomeds have a drawer or a container full of different types of fasteners. Like I've got a drawer or a container full of metal screws. You never know when you need one of these bad boys. So at work, I have, different sections of different types of screws. So if it's a plastic screw, if it's a metal screw, if it's a precision screw, and I try and separate them by metric standard if I can figure it out, but it's not always necessary. Right, wow, look at all the drivers I had to use for that guy. Oh boy. All right, for this guy, I'm gonna have to glove up. Hold on. So for most of these medical devices, they can be absolutely disgusting, all right? And this one that I'm about to open, I have no idea. Just judging by the outside, you never know what you're going to get when you open them up. So gloves, of course. Save that one. Now, I know they still sell these devices, and you can still get them repaired. But this one right here is an example of an old one from back in the day. This is a Doppler. Now, a lot of you guys probably recognize this. I mean, these have been a staple for 20 some years, something like that. I think they still make the exact same. They still sell these just like this. There's a few revisions on the inside, but it's pretty much the same metal box, the same exact contents. There are a few minor differences here and there. I think there's a couple different frequencies of the probes, but this is a Doppler. And because it's a Doppler, they normally use it to detect blood flow, especially when they do surgical procedures and they want to detect if they have flow after the fact, because sometimes swelling and stuff will cease blood flow through tissue when it's sealed back together. So they will probe on capillaries and stuff around the surgical site to make sure that they still have blood flow. Because if you don't, the tissue goes, it dies really quickly. So this is a Doppler, and I see that there's all sorts of corrosion on it. This guy has just been around the block a few times, which is why I'm putting on the gloves. So there's normally like a pen type. There's a pen type Doppler probe, which the very end of the pen is the actual ultrasound. And what it does, it shoots sound out and it listens for it to come back. And it allows them to hear things that you normally can't hear with like a microphone, like blood flow through tissue. So you have to really listen because there's a lot of static, like an old AM radio. There's a lot of static on these guys. And especially if you have a bad probe or if you have corroded RCAs. Here, let me tune this guy down. So here's where the probe connects. There's two RCA jacks. There's a charging port. There's earphones, although I've never ever seen somebody use earphones. They always just use it through the loudspeaker. You have on and off knob, and you have a volume, all right? These guys have all sorts of problems. Obviously, it's an old device. Here, I'm just going to dump the screws out because there's no chance that this guy is getting put back together. There is also a miniature battery in there. Oh, wow. Hidden treasure. Do you guys see this? Why the hell would somebody have that inside the device? So here are two replacement RCA jacks for the front of this guy. Yeah. So you can desolder your RCAs and solder these ones on. This was just floating around on the inside of the case, and it's a little baggy. How crazy is that? That is insane. All right, and it's got an old ass battery. Oh yeah, the date on the battery is 5 of 2010. So it has been in there for a while. Some other cool things about these guys. Back in the day, they used to have information inside medical equipment, like a schematic. What? Take a look at this, guys. Old medical equipment almost always used to have a schematic up inside it, just like washers and dryers used to have schematics on them. I mean, hell, I think you could even open up a toaster and see schematics on the inside back in the day. But then it's got some information for the people right here. And I have a date inside here of 7 of 1997. So who's to say how old this guy really is? But it's at least 20 years old. Yeah, take a look at that. So this schematic right here, that's actually, I'll probably scan that in. That's very cool. So we could actually follow the circuit because this is all through hole. You see that? See the planes on the back? So you can follow your DC bus. Wow, this is a simpler version than some of the other ones I've seen. Very, very cool. Okay, so it says right here that this one here is from 12 of 99. I've got a date right here. Now that could be a refurb date because this company, if I were to ship this out to them, they will refurb this even to this day and send it back to me. Refurbish. And that is almost crazy, but this company right here has been, I guess, fantastic at supporting their product. I mean, to this day, they still sell almost this exact thing. So let's see. I can see from the charger how the power comes in. It's got a circuit right here that's for the 811 BTS, which this is the 811B. So that is not on this one. And down here is the audio amplifying circuit. Down here is the speaker, the earphones, and it shows me pinouts of some of the other stuff along with the transistors that are going along with them. Very cool, man. And wow, there's a change log. How crazy is this? So it says there's a change log up to 2 April 1999, and it's the change log is as simple as corrected position LED number 1 and number 2. Change R23 to 1 meg. So I mean that's very cool to see the lineage of this product. And over here I have a complete breakdown of every single capacitor and every single resistor, all their values and their number value on where they are inside the product. So that means that they're all labeled on here, right? We're gonna find out. We're gonna open her up. That's a bygone era right there. Having schematics on the inside of a product. I kind of miss those days, man. I miss those days. Here, disconnect this battery. I bet you it's dead as it can get, but let me disconnect it just to be safe. You can see right here, it's got a large non-soldered fuse. Let me pull this guy out. Come on, there we go. So it's got a replaceable fuse right there. I'll tell you, these products were designed to be maintained. Oh, geez, I don't even know if I can get those knobs off. The set screws on these knobs look like they got blood or something up inside them. Yuck. All right. well, this is going to be a problem because all these wires are through-hole soldered, and because they're through-hole soldered, I can't just disconnect them like I could on a modern-day appliance. Yeah, see. Wow. That's a cool find. This rotary knob, it's got exposed contacts. So if you had bad connection, you could actually, I don't know if you guys know this, but back in the day, there used to be contact cleaner, like it was almost like a really fine sandpaper, and it was a file, and there's different gauges that you could pull out of the device. I probably have one around here someplace, but it used to be a contact cleaner, and you'd pull one of them out, you'd stick in the end, and you'd slide that in there, and you would clean off the face of the contacts. Yeah. So that's really unusual to see an open-faced switch like that. Obviously, it's probably not rated for 120 volts and up. You know, it's just switching 12 volts DC, I think. That's what this guy is. Wow. Let me tell you, this double-sided foam tape that they use in these guys is vicious. This shit was not gonna go bad anytime soon. There we go. All right. Yeah, it's a 2010 battery. Nice. So on the back side of this card, this looks like it's all completely hand soldered, every single joint on here. And to be critical, I would say that whoever did this is not the greatest solderer. You can see your adjustment points though. See on all these, what the hell are those? Are those adjustable, they're not potentiometers. Hey Bjorn, do you know what the hell these things are? Are these adjustable inductors? Because there's little capacitors here, and it looks like those are adjustable inductors. Let's see. Yeah, so you stick this guy in here, and you rotate it, like so, to tune it. And I would assume to tune this guy, you would probably throw a waveform probably into the 8.9 megahertz probe with a signal generator, and you would probably look at the earphones, the output, and you'd tune it to make sure that you have a good signal. Yeah, it's definitely some old school stuff. I was planning on pulling these apart, but you can see, look at the shmoo down in the set screw holes. So this guy is a total loss. Some cool stuff on there though. The electrolytics are not going bad yet. Kind of surprised about that. So these guys right here, these are electrolytic capacitors, and they do have a tendency to leak. So right here near this end, there's a little weep hole, and I always see these things leak, especially when they're in audio products like guitar amplifiers. You always replace these whenever you open up your guitar amp. Yeah. Oh well, it is what it is. Man, now my mat is all dirty. Yeah. Very cool find though. Some RCA jacks inside the product. They know that it was going to go bad, and I scored a very neat fuse. So that is a Doppler, and believe it or not, the new revisions of this Doppler are not that different from this one right here. They are extremely similar. The company, this company right here, still sells these things. And I think it's Parks Medical, isn't it? Anyway, they still sell these to this day. And obviously, you know, it's not the exact same one, but pretty darn close. And I'm certain that you can take almost any of these ones back. You ship it back to them. They'll refurbish it for like $400 or $500, and you get a refurbed unit back in the mail. All right, let me. So that's the good thing about using these mats. You can clean them off, whatever. I have some wipes. Use wipes because that's some nasty stuff up inside that Doppler. All right. I have a let's see. I have a couple other things that I want to show you guys. I don't know. Should I save the best for last? I have a very cool find right here. And I want to tear into it so bad because I've seen it for months, actually for over a year. I've seen it sitting on a shelf. It's like, why the hell are we saving this? But oh well, I grabbed it, I brought it home, and here I am tearing this stuff apart right here at my home. And obviously, almost all this stuff is going to go back in the trash. This is garbage. All right, what do we got? Oh my gosh. Hell yeah, let's do it. Guys, I found this product today, and I am so excited. All right, this right here. I've never ever seen one of these like this on the market. I've seen other versions, but I've never seen this. This is a line isolation monitor tester. Okay, how cool is that? So I've done several videos on line isolation monitors and isolated power and yada, yada, yada. Isolated power is just like the GFCI outlets that are at your house, except the GFCI, when it detects a ground fault condition, which means there's current going on the ground wire, they will disconnect. These ones right here in hospitals will not disconnect, okay? They will alarm when they get to 5 milliamps or 5 microamps. Anyway, they will alarm, and it's milliamps. Yeah, it's 5 milliamps. They'll alarm at 5, but they will not disconnect because you're treating a patient, so that it can't disconnect. But the thing is we biomeds back in the day, we used to test these things. And I was asking lots of people, how the hell did you guys used to test these things? And I found one in the trash, basically, but I pulled it out of the trash because how cool is this? You have your receptacle tester right here, and then you have a series of selectors off the side. Now, most of this is not going to be used. You can see right here a GFI trip. There's a line volts. Do you really have to set these up point by point? Oh, that's so wild. So you can see on the gauge, I've used so many analyzers over the years. I've never used one like this. So you can see right here on the gauge that you have voltage. You have, what's the next one? So there's kiloohms and there's milliamps. And based on whether or not it's 220 volt or 120, that would determine where this potentiometer is. Now, mind you, it's only 5 milliamps. It's tiny. It's a tiny amount of electricity. That's all it takes to make this guy, alarm or test a circuit. But so I have a GFI trip point right here. It's a scale of 1 to 10 or 2 to 18 milliamps. And then up here, I have the limb trip point. And the limb trip point, it goes to 0.45 to 0.83. And it goes to 7.2 milliamps to 13 milliamps based on what 120 or 220 volts. So for me, if I was testing a limb, typical usage on a line isolation monitor is going to be between 1 and 3 milliamps. It's an extremely low amount of leakage. But what you want to do is you want to run it up to about 4.5 and check the limb panel to see if it shows amber, which is a warning like, hey, watch it, bud. And then when you get to 5, boop, then you can limb trip, and there you go. So once you get to 5, but the cool thing is about this guy, look at the top. I can hook up a multimeter, and I can actually watch on my multimeter as I'm setting this guy. That's pretty cool, man. I've never, ever seen one like this before. When I was working at the Medical University of South Carolina, I actually built one of these from scratch. just using my knowledge of how a line isolation monitor works. And I created a leakage with a potentiometer between one of the legs and ground, and I fed it through a receptacle just like this. But in order for me to do it, I had a spot just like this for my multimeter. You set your multimeter up, and then I had a jumper that you had to put across this guy. And it was basically a female plug. You pop it on this guy, and it was basically jumpered. And what you did is you set the resistance with the potentiometer using your multimeter. And once you got it to the set resistance for like 4.5 milliamps, that's when you pull your multimeter off, you pull the jumper off, and now you plug it in. And now you can read, you can test your electrical outlets around your operating room for isolated power. This is such a cool guy. It's a Biotech universal ISO tester. You betcha when there's nobody in an operating room, I'm going to go plug this guy in and I'm going to give it a check. Because if this guy still works, what a win this is, man. Now, the limb trip A and B, there's not a button on there, which is kind of a shame, but like macro B, I don't need macro B, okay? So I'll just move the buttons down. Yeah, just like that. So limb trip A is what you're usually going to use. I'll probably have to read up and see how the hell you're even supposed to use this. What a cool device. Whatever. But anyway, I found this guy in the trash, and as soon as I seen it sitting there, I was immediately excited. Oh, look at this. They're so good. On the back, they show you a little schematic of how to hook up your multimeter for testing. Okay, it says turn isolator off, connect universal ISO tester to the Biotech model as shown, push chassis leakage button on the safety analyzer. Oh, no kidding. So this is used in tandem with a Biotech safety analyzer, which I obviously don't have a Biotech safety analyzer. I don't even know if I've even seen one lately. But just the fact that I have this device, I'll do some more research on it. And you betcha I'm going to go into an operating room when there's nobody there, and I am going to give it a hot supper. I'm just going to run it through the paces to see if this guy still functions independent without the safety analyzer. What a cool find, though. If anything, there's really good parts inside this. You know something? This is a teardown video. It wouldn't be much of a teardown video if I didn't tear down the safety analyzer, so we could take a look inside it and see what the hell is going on in this guy. I'm assuming that it's creating a leakage between L1 or L2 and ground, and all you're doing is you're switching it on and off and adjusting it with the potentiometer. But I don't know. Maybe there's some other funny stuff going on. All right, let's see. Come on. Guys, I think I've had way too much caffeine today. Way too much. I'll tell you what, 2 cups of coffee and I'm good. It's going to be a very productive day. 3 cups of coffee and I'm on the verge of losing my job because I'm going to say some truth. Whatever the situation is, man, I'll tell you what, 3 cups of coffee and I got to watch myself. Like, I don't know, for whatever reason, that reply to all button in your email, it just gets more and more tempting the more caffeine I have. Let's pull all the buttons off. Wow. Okay, very cool. There's some old school stuff in this guy. It's all through hole. Of course, this is back in the day. I would really wish I had a date on it, though. Is there a date on the back? There's no copyright date, no nothing. There's no molding date like you would normally find in a modern day stuff. Oh, what is this? Okay, well, you can see that this right here is for your mains. It goes obviously through your 2 fuses for L1 and L2, because in isolated power, you have 60 volts and 60 volts, or, 120, 120 if you're in Europe. And let's see, So this right here is your first potentiometer, and this one right here is your second one. And all these guys right here, they just flip-flop between them. All right, hold on. Let me see if I can get my Phillips screwdriver to pull it apart further. Wow, I do dig these through-hole circuit boards from back in the day. I love it, man. Come on. Did I get them all? 1, 2, 3. No, I didn't. Hold on. I need some pliers. All right. I'm being held up by these these fuse holders. There we go. Come on. Can I just lift it off? Yeah, I can. All right, cool. One more Phillips screw. Flip-flop back to this tool again so I can get at these spade connectors. Come on. There we go. All right. And I'll tell you what, if anybody's watching this that is not a Biomed, old Biomed equipment is some of the coolest equipment that you will find out there, for sure. We have some of the coolest stuff I have ever imagined. Wow. Okay, so I can see that they're collet nuts. Collet nut is one that you screw it down and it expands or contracts, and using just tension is how it's held on in place. And that is what this guy looks like. And the only way to get it, there's normally like a spanning wrench that goes right here, and it's not going to allow me to do it. Oh well. What do we got? Oh, guys, this is going to drive me crazy. I got to get these off. I have got to get these off. Oh, there we go. There we go. Okay. I see the game plan. All right. Maybe I will not be using this in the future because I'm going to break this guy right off. Yep. All right. I can still test it with these guys. Well, I was expecting more on the back side of this. So just through hole on the switches. Look at those old school switches. And this large 900 ohm resistor. What is this? 5-watt resistor? Something like that. Not very big. So that's a 900 ohm. This is a 10 ohm 250 watt resistor. So quite the difference there, eh? So that's I believe that that's all it's doing. I could probably test it with my multimeter. It's probably going between L1 and L2 and ground, which is this one right here. And by you activating like this switch here, it's probably going through the 900 ohm and through the potentiometer. And that's going to give you the quantity of leakage. It's a certain quantity of ohms between like 60 volts and ground. That's going to give you a a leakage of 5 milliamps. Wow, very cool. Lots more old school stuff. Now these jacks right here are going to be useful in the future though. These ports for banana plugs. So I'll probably end up saving those. And probably these fuse holders. It's a box with calculated resistors for each trip level to test. Well, it's got a baseline resistor of 900 ohms. You can see that. And obviously, since it's a power resistor, yes. But also, your potentiometer is going to be your adjustment, you know, from your 0.45 to 7.2. So it's a little more engineered than I thought it was going to be, because I didn't use any power resistors in mine that I built in the University of South Carolina. What I did is I actually put several like 1 watt resistors in parallel, and using my multimeter, you know, just keep combining them until you get the selected amount of resistance to get you down to, let's see, what did I get it to, like 4 milliamps, and then use the potentiometer to, you know, add just enough ohms more to get you to 5 milliamps, which would make your limb panel alarm. So I might actually have that one here someplace. I don't know. Maybe I kept it. This is a line isolation monitor. I'm still going to fix it, and I'm still going to test it. That is a cool piece of tech. A lot of biomeds do not know about testing line isolation systems anymore. They used to. Oh, here. I didn't break those. I thought I broke them. Here's that collet nut that I was telling you guys about. You can see right here that as you screw it down, oh, here, let me just take it apart. So that right there is your tensioning mechanism. This right here is your collet. Okay, there's tiny little lines cut into it. See that? So what it does is it goes over the stem. That's very cool. I thought I had broke it, but what happened is somebody cut them off. So your collet fits over it, and then as you screw it down, it clamps it. And a lot of older medical devices, that would be how you would adjust it. You have a potentiometer or a needle valve, and you would have a collet that you'd have to loosen up. Draeger anesthesia machines are a perfect example for like your flow meter. You have a collet that you have to loosen it up. You adjust the knob to a certain percentage, and then you tighten the collet back down according to what you're reading on your instruments. So very cool. There's a brass collet. They steal those from Dremel. I'm pretty sure Dremel's been around for a while, which I have an old Dremel. I have an old Dremel here someplace. It's one of the old brown ones from way back in the day, like the 50s or 60s. But yeah, collets have been around for a long time. Look at all this stuff. Woo. All right, I'm going to pull out the big guy, because this one, I have been itching to pull this guy apart for the last year. All right, let me get another glove, because like I said, I don't know what's inside these things. It's going to take my whole desktop too, so I might have to pan the camera up a little bit. Let's just do that right now. Oh my gosh. DJ, what's up, man? Tonight we are tearing down some history, okay? I first started off, I tore down a 3-channel infusion pump from back in the day, from the 1990s. This was an in-light, in-surgical light video camera, analog video, of course. This was from back in the day. This next one, I wish I could power it up to show you guys, because this one, I still have a couple of these in rooms, so I want to just tear the hell out of it. But you're going to have a down room if this control panel goes out, so I'm kind of on the fence. Should I tear it apart and just say I don't have any extra parts? Kind of thinking that, because this guy is from back in the 90s too, It's a control panel for surgical lights. I have the whole stupid control panel, the whole thing. And this is an old Steris control panel, and it has a status panel in it, an LCD from back in the day. And the problem with a lot of these LCD panels from back then, they all are kind of washing out, right? The backlight isn't working so well anymore. A lot of them have burn-in, because old LCDs had really bad burn-in problems. But let me pull it up here so that you guys can take a look, because this guy, it's got a whole bunch of treasure on the inside, and I think I'm gonna have to do this one stand up, because this guy is gonna be very heavy. It's like my personal treasure. All right. Here we go. This is Steris Harmony lights. This is the whole control panel right here. So it does have some membrane buttons on the front, so you can control some rudimentary functions like your power on, power off. Guys, I hate membrane buttons. They're easy to clean and everything, but they go bad. I hate membrane buttons. This panel right here, this is old, man. It has that creak to it when I pick it up. The plastic's getting old. There's some stuff about this guy that I really miss. It's got a legend on the back that shows you your pinout for your cabling. Man, I love that stuff, because they don't do that kind of stuff anymore. Now your installer might have a legend on his install manual, but we won't ever get that. So I do like this. I love that. But anyway, this guy, the Harmony series, this is from back. Come on, video. Come on, video. Please, video. This guy is from back in the 90s. This is an LCD display, and you would control your operating room lights from this, like light head 1, light head 2, light head 3, maybe a light head 4. And I'm seeing some stuff on this panel that makes me a little concerned, because this one looks like it also controlled some video routing, like maybe for the in-light camera, like the camera I tore apart, because that was a Steris camera. So maybe the video was routed using this panel. I don't know. We'll open it up. We'll take a look. I see a coax jack on the back of it, which makes me think the camera ran straight into here. On modern day operating rooms, you have to have the lights on for most of them in order for you to have camera power. So this one here, I assume it's the same. You have to turn it on. It's an all-in-one unit. Now, this is only one component to surgical lights. So back in the day of this one right here, OR lights were halogen bulbs. Okay, halogen bulbs are what, 200 watts, something like that, 100 watts, and they burn hot and they eventually go bad. It's a bulb, But in order for you to run one of those bulbs, you had to have a transformer, a step-down transformer, because your power above a lot of operating rooms, well, you have your regular lighting, which is what, 270 volts, and you have 220 volts above a lot of ceilings, and you obviously have 120 volts. So you have a giant transformer above the old operating rooms where you have taps, and you adjust your taps. You do it when you install it, and over a period of time, if you start blowing more and more bulbs, you would have to go up there and you would have to do a voltage reading and change your taps on your transformer. So anyway, the newer lights are all LED. And not only is that incredibly lower maintenance, there's lower amounts of heat. You have a more pure frequency of light. Like you can adjust your LED lights for 4,500 Kelvin to 5,000 Kelvin to 6,500 Kelvin, which is like extremely white light. But depending on what you're doing, having those variable frequencies of light is going to help you out a lot. It's going to see your differences of tissue. Like if you're doing cancer or something, believe it or not, cancer has like a different color than regular tissue. Also, obviously, if you are looking at nerves are going to have a different color. So being able to adjust your frequency of light, you know, some people like more yellow light. More people like more white light. Doctors like lots of light. That's all. One thing doctors love is incredibly powerful light. And the thing with halogens is you would have to have these lights right near your head if you're a surgeon. And halogens, like I said, they give off a lot of UV, ultraviolet light, and they're also hot, okay? And the problem is they often have a backup bulb inside them, because when a bulb goes out, some of them have a little motor and they actuate the other bulb and they turn it on. Some of them you had to manually go up there and flip the bulb, and some of them don't have a spare bulb at all. Just depends on which one you got. This one here, the Harmony series from Steris, we still have some of these in service. Hopefully not anymore. I'm hoping after these construction projects, this stuff's gone, because you have this component. You have the transformer above ceiling, which those transformers with age, you know, because they heat up, they cool down, they heat up and cool down, 20 to 30 years of that. Transformers, you know, the wires that are in there, with the heating up and cooling down, sometimes the, what the hell would you call it? Wait, the wires heating up and cooling down eventually over time start to wear away. And when that happens, they start forming shorts. Well, a transformer is generally a short anyway. So what it does is when you start getting shorts in a transformer, it not only creates a hot spot, but it also changes the output of the transformer, because you are now closing off and you're getting rid of some of your coils, okay? So it just happens. And I have some excellent examples of transformer fires because over time they eventually start wearing away, and then you start getting these weird quirks. With these lights right here, I have seen where you start going through bulbs, and you start going through bulbs because your transformer no longer has the same output that it used to. It happens, and you can go up there and you can check it yourself. You can pull down your light head, stick your multimeter in there, and turn your lights on, and read your voltage output on your multimeter. You can figure it out. There's going to be some creep based on when they installed it for these old systems. Let's take a look. This guy is pretty cool. Take this. This is the remote control for the lights. They had a remote control, and it's infrared. Back in the day, everything was infrared. And the problem is infrared has some huge drawbacks. Depending on your environment, infrared does not do so well. It does not do so well in daylight, and it doesn't do so well unless there's a direct line of sight. So you'd be standing there like, you might as well just get your happy butt up and go and hit the button. I guess these worked. I guess. You can see that there is zoom for the camera. You can rotate the camera, which is that little rotator motor that I was talking about, and focus. You can adjust your focus. Pretty cool. But there it is, stuck on the side, a control for a Steris Harmony camera. Let's pull this guy apart so you can see the inside, all the goodies. Come on. I did have it apart earlier, so I know it'll just pull apart. There we go. All right. Come on. So this seems to be a going theme. There is one of those fragile membrane button ribbon cables. And inside this bad boy, look at this. Look at this monster power supply right here. Look at that guy. That guy is probably still good. I bet you it's still good. This is actually really clean. There's a little bit of dust over here on this fan and this power supply. Let's pull it apart and see what the output is on this power supply, man. I'm very curious. You can see right here your infrared. What? Right here's your infrared for that fancy dancy remote control. It is a daughter board. You can see that. It's connected with a ribbon cable. Yeah, there's two power supplies in here. How fancy. Okay. Screw it. Let's get into it. So one indicator that this is some old school stuff is there's flat blade screws that are securing it to the front panel. So look at this. So these flat screws, and I do believe that's holding it's holding the power supply to this panel, which is really kind of goofy because if you want to change your power supply, you have to pull the whole panel off the wall, get to the back side just to change out a power supply. And if you guys know my videos, I talk all the time about how power supplies are the Achilles heel of every device in the world. I mean, the power supply is where stuff goes wrong every time, unequivocally. All right. I think that is it for that one. Wow. Yeah, that's definitely a trademark of the 1980s and 1990s is flat blade screws. They were just nuts about these back in the day, weren't they? Everything is flat blades. Shoot, even these, so these right here look like they're a voltage breakout board. Let's see. Well, we can see up here. Okay, those are for these. White, black, and shield. So you can see how the power comes in and it goes through the breakout board. And then, okay, so this one here says that this is 2003. Okay, so this cable right here says 2003. This one right here says 2005. But this one looks very new, so this one might be like an addition. If they changed out the camera or they added a camera to the room or something, that could have been added later. So we got these. I love these connectors. These you find it on industrial electronics all the time. Tiny little flat blade screwdriver. So this is why I encourage Biomeds to have tiny little precision flat blades. It's because you'll always run into this in the field, especially on some of the heavier duty appliances. Come on, man. There we go. Jeez. Huh. All right, let me just pull this breakout board off. I don't see anything fancy on these things. There's a couple chips, but it looks like all it does is your power gets split. There's one test point. Okay, so it's plus 24 volt and ground, so that's it. Anyway, let's pull all this off because I want to really tear into this guy and see what's going on. I think the last place I had one of these lights was a cath lab. I'll talk about cath labs some other day. If you guys don't know what a cath lab is, that's where they run different types of catheters in the human body, and they have X-ray in the room so that they can use it to guide the physician to where they got to go with the catheter. But I have one of these in a cath lab that's getting redone as we speak. As we speak, they're doing construction on that room. So I do not think I will ever use one of these guys again. Come on. There we go. And let's pull this guy apart. Wow. All right. So I have a couple RF antennas on this guy, or they're not antennas. Remember how I said that old composite video used to come through across on coax? Well, this is the type of coax cable right here that they would run through the booms. And I believe your video comes into this guy right here. Let's see if I can show you. So you can see right here are your RF connectors. Yep. There it is. Let's see if I can pull one of these out so I can show you guys what it looks like. Man, I'll tell you what, I do love tearing some old stuff apart. Ah. Hold on. Let me just separate some of this. There is a very large ribbon cable right there. Make sure I get this power supply out. I'm going to pull both the power supplies off. If there's one good thing that's going to come off of this, it's going to be those stupid power supplies that are on the back side. I found this on a shelf in storage. And believe me, I've got 20 to 30 years worth of stuff in storage. And they left it up to me to try and clean up the shop. So I have all sorts of stuff that I'm going through, I'm getting rid of. There's probably hundreds of thousands of dollars worth of parts and old equipment. Just like that telemetry server that I did a teardown the other day of. Yeah, that came from the same exact room. So there's hundreds of thousands of dollars, if not millions of dollars worth of stuff that's like on old shelving units and boxes, just stacked up, man. All sorts of stuff. It's an absolute haven if somebody were to come in with a flatbed trailer and just load up all that stuff and put it on the bucket. Because someplace, somewhere, there are hospitals that still have these in service, and I can imagine that they would love to get some of these components. So this one right here says 07. This one here says 05. So I'm getting different dates on one side than the other. So there's definitely an upgrade going on here. Okay, let's see. What is the power supplies? All right. There we go. Okay. So from this side, I've got all my primaries on these power supplies, and then we're good. All right. You know, I know it's a switch mode power supply, but for as big as this is, it's definitely not very heavy. And looking through the grate, you can see where the power supply really is. It's just a large open shell. This one on the other side, this one is heavy. Wow. So we know that one of them is a 24-volt power supply. And the other one, I would maybe assume, is a 12-volt power supply to power, you know, all this stuff in the camera. I don't know. Let's take a look. There you go. Wow, this one's not as heavy as I thought either. Okay, I'm going to put him off to the side. Whew. If there's one thing that I love acquiring, it's power supplies. And these ones do not smell like brown sugar, so these ones are still good. I can promise you, we put AC power to this, and this guy's going to power right up. I'm going to remove it from its shield. Now, in the last video, I talked about having RF shields, and this outer component right here is just that. It's an RF shield. It's overbuilt for a purpose because this is going to be in operating rooms. And inside it is just a generic Condor power supply. You guys are wondering why I'm sniffing power supplies. It's because you can tell a lot about a power supply based on the smell. You can tell if there's burnt components. You can tell if your transformer got a little wee bit too hot. but I bet you this guy's going to power right up. So we have our primaries over here, and our output is over here. What is this guy? Is this 24 volt? No, this is a 12 volt. Okay. So we got 12 volts and 24 volts coming off this guy. And this one here does have a sense line. So in another video, I told you guys that a lot of power supplies will have a feedback sense line. So if you push the power button on your console, what it does, it comes over and it shorts these pins here, which tells it to turn on. So there's normally like a T2, which is a smaller transformer. It's probably this little guy right up here. And this tiny little transformer will sip a tiny amount of electricity. And what it does is it creates the standby signal, okay? And the standby signal is what comes back over here. You can see it says right here, pin 4 is plus and minus of sense. And that sense is what turns this guy on remotely, okay? So there's a little bit of voltage that goes out, and it's looking for a return or a drop in voltage, and it's going to turn the whole thing on. So regular power supply, you have your AC that comes in, fused, your power filter, inductors, and capacitors, and then it goes right here, your bridge rectifier. Bridge rectifier turns it into high voltage DC, and then it's going to come over here, and it's going to chop it. Really high frequency, and it's going to drive it at a high frequency through this transformer. And once it's through this transformer here, it's going to step it down to when it goes through rectifying diodes. And from there, it's going to do some other stuff. It's going to split it off, and it's going to step it up, step it down, depending on your output voltage. Obviously, this has got 12 volts for the fan. So it's got a 12 volt output, and it's got a 24 volt, which means that there's probably different taps on. There's a couple different secondaries on this transformer here. But anyway, you can see right here, this board right here is your monitoring board, and it is your loop back for your optical isolator. And your opto isolator, man, I don't know if I can show it to you guys. So there's a separation under this transformer between one side and the other, and in order to control your voltage on this side, it has to go through an opto isolator. So basically, there's an LED on one side, and the brighter it gets, which means the more voltage output. On this side, it's going to have a detector, okay? So there's nothing physically connecting this side and this side, right? So as it gets brighter, this side here knows, hey, it's driving it too much, and it limits it, okay? So it's current limiting using an opto isolator. And this board right here is the one that controls a lot of that. And you can see the separation in the PCB. You can see right here, it goes down like this, and it goes right under this transformer, and all the way over to here. So that separates your board just like that in two different sides. And this side of the board cannot physically touch this side, or else you'll get interference and a bunch of other stuff. So that's why they use that opto isolator. And you can see right here that you can adjust the opto isolator for how much it sees using this guy. Right? So that's your adjustment point, one of them anyway. And right here's the other voltage adjustment. Very cool, man. So Condor power supply. This guy is going to get saved. If there's one component that's going to go bad in the future, it's going to be a power supply, but we could always use power supplies, man. The yellowish component is Kapton tape. You're actually right. The Kapton tape is a thermally safe tape. It does not like catching on fire, and we wrap it on bulbs. Use Kapton tape on components. You use it when you're soldering. You use Kapton tape when you're soldering on a component. So if I'm soldering this component here and I want to protect the components around it, if I'm going to use this bad boy, my hot air gun, you'll put Kapton tape over the components around the one that you want. So when you blast air down on it, you're actually protecting the solder right here. So all you have to do is keep the solder at a lower temperature here than right here. This component will come loose, and these ones here will not blow all over the place. So when you use hot air guns, Kapton tape is a very good thing to have around. And I have some in a box over there someplace. Man, Bjorn, you know, man, I've seen your lab. You've got a bunch of old shit in your lab too. It's all good. You were absolutely correct on the power supply is double shielded because, well, it's not for the camera. You have to remember they're double shielded for, well, okay, so it could be because it's analog video. But also, you have to remember these power supplies are noisy as hell. Look at this. There's no RF shielding on this power supply, so they have to put a baker's box on it, okay? Because this will mess up other things in an operating room, like your EKG signal, your EEG signal, which is monitoring the electrodes in your head for neurosurgery. So you gotta put something over these guys and make sure that that bad boy is grounded, because you do not want a bunch of stray RF noise in an operating room. It's big no-no. Let's pull this guy apart, see what's going on in it. It's another power supply, but this one's a wee bit different. This one does have the integrated RF shield from what I can see. Ha! I like that external fan. So this is the RF shielding that I was talking about. The other one is missing. Is it spare parts? This one is a Conversion Devices Incorporated. This is also a 24 volt, 275 watt. So, interesting. This one looks way newer than the other one. So the other one looks like the OEM original. And I would say when I was talking about there looks like an upgrade or something later in time, this was probably part of that upgrade. It just looks like it. The components look newer. Everything about it looks way newer. It looks way cleaner. Take a look at that. That's amazing. I mean, I would expect all sorts of dust to be built up in there. Nothing. So this guy is almost definitely good. So I got two 24 volt power supplies out of this bad boy. I love it. Oh, hold on, guys. Hold on. Hey, bud. Are you coming into my shop without shoes on? What are you doing? Hold on. Hold on. Today's got gloves on.
What are you doing?
What am I doing? I'm tearing stuff apart. What does it look like I'm doing? Huh? Okay. What?
What?
What's this? Are you invading my space? Okay. Here, here, don't walk all over the place. I'll probably have metal slivers here. Here, come here. Come here. Come here. Ah! You're so heavy. Here. You gonna say hi?
Hi.
Okay, what are you guys doing? You trying to get me? Huh? Oh, that's beautiful.
Yeah, we're making it out of that.
Okay.
Ew, God, where the dinosaur was.
That's wonderful, sweetie.
We're going to the picture to find the golden treasure from the dinosaur world.
Oh, really?
Yeah, we're going on a trip.
Oh, wow.
Candy.
All right. Well, the rest of the stuff in this guy is really not that fancy. So,
the dinosaur just passed me last week, so now I need to run from the dinosaur.
hey, is it almost time for you guys to go to bed?
Yeah.
Yeah, you're right, bud. So, why don't you, hey,
The golden treasure.
why don't you guys go put your PJs on, okay?
Need to find the golden treasure quick,
You go put your PJs on too. Although I don't think you changed out of your PJs. Okay. All right. Come on. I'll see you in a little bit. Okay. Go change your PJs. Okay. All right, bud. Thank you. These power supplies are not certified the way that you would think. Power supplies from computers are, you know, when they say like bronze, gold, and all that, I don't completely believe that. And it is what it is, man. The component in the middle. I don't know what you're talking about, man. Hold on. Oh, you mean the thing that's covered in the transformers Kapton tape? Yes, it is. That yellow. It's also the yellowish tape I pulled off some of those ribbon cables earlier. That was Kapton tape. This is what he's talking about right here. That's what that stuff is called, and it's a electrician's universal tape. What you doing? No! Don't do that in here. Daddy's got. You're gonna get so dirty in here, and I'm pulling apart medical equipment. And this stuff is Okay, close the door. Okay. I'll see you soon. All right. Oh my gosh. Hold on, Bjorn. Hold on. You're talking about this guy is a choke coil. This large inductor right here. This guy right here is a choke coil. Yes. This guy here is your second transformer. You found a vintage EKG? Man, I'll tell you what. I dig some old EKGs, man. Because you used to have to I do not know what you're talking about, man. So what you're saying, hold on. These are choke coils. And I see what you're saying. You're saying this guy right here, this one, right? There's no brand on this guy. You're fucking with me now. You're messing with me now. Anyway, the part that you call a transformer. This is a transformer, and this is a transformer. They're different types of transformers, but they're both transformers. What's up? Okay, don't come in here. You're dirty. Don't get dirty, man. Hey, bud. Go inside, okay?
Okay.
I'll be in just a minute to see you, okay?
Okay.
Okay, I just don't want you getting dirty. Because you're a dirty boy. It's a choke coil. Man, you're wrong. That is definitely a transformer. This guy right here, this guy right here, this guy right here is a transformer. This one is 100%. 100%. You call it a choke coil. In fact, I'm looking to see its designation so I could look it up and show you. But it's even got the markings for the secondaries. Look, there is no Hitachi logo on there. Now you're just crazy. There's no Hitachi logo on there. I don't see any logo on there. I see PL, and it says Condor Incorporated. Right there. It says Condor Incorporated right on it. So it's Condor brand. Not Hitachi. It's not. Okay? That is a transformer. What you doing? Here. You want to sit up here with me?
Yeah.
Okay, come here. Why don't you come on up? All right. You sit on this chair so you don't fall over. Okay? All right. Tell you what. You can play with some breakout boards. Okay.
Okay.
All right. Cool. Here. Come on. So we're gonna finish up this device. There is just one major component left. So an old school feature. There's a foot control right here that connects through this port. And on this one, right here, we have, so this one here is an analog video board. And shit, I don't even know what else there is to it. So that would be how you do video out. Definitely weird. The modern day ones do not incorporate video into They don't incorporate video into the light at all. So that's the Steris. All right. You want to try what?
Yeah.
No.
Why?
Because I said no. The last thing that I am going to take apart is a device that drove me absolutely crazy this week because this stupid thing right here created some hell for me because the customer is being overzealous. He didn't want to pay for it. And with my, hey, sweetie, no. Hey, if you're going to be in here, you got to be quiet, okay? Okay, thank you. Here, you want to come up here with me?
Yeah.
Okay, all right, come on, up. Arms. Okay, you're going to sit right here, all right? Okay, what's this? Do you know what that is?
Yeah.
What is it?
It's a generator.
It's a printer.
It's a printer.
It's a printer, that's right. And it takes labels. So you would think that a label printer is just a low dollar item, just regular, shouldn't be a pain in the ass. It is a pain in the ass because this company right here, Cytyc, CYTYC, was bought out by Hologic, and this brand printer, here, hold on. This brand printer right here, this Dymo, the SE300, SE stands for serial because it communicates with serial through, what is that, an RJ11 connector? So
Hello.
serial.
Okay.
So this guy here, I tried cleaning it up. It's got an issue where it randomly prints black lines, and that's it. And I thought I could salvage it. This goes to a lab analyzer, and this was a pain in my ass because I cannot find this printer except on eBay. Hospitals do not like buying stuff from eBay. So I basically had to tell them today, tell you what, go out and buy your own someplace because I've got so much other stuff to do at work, it's not even funny. Here, I'm going to pull this cover off, right? There we go. Okay, let's pull the cover off. All right, so you see, we got some screws up in there. So we're going to open this guy up so everybody can see how ridiculous it is. Right, and then this pulls off. Whoop.
Can I see what it prints?
Okay, it prints right here. Okay, so this is called a thermal printer. Okay, so it uses heat. It uses heat to print on here. See this? I bet you we can get it to print just by rubbing on it.
I like to see it print.
So it uses heat to create words and lines and stuff. Okay.
I can pull anything out with this printer.
You can pull anything out. I hope you don't pull anything out, right? Because
Anything will be done when I do this one.
oh yeah, okay.
I didn't want to let them get out. Oh, no.
You should be part of my streams more often. You know that.
I can help people when someone be wrong.
All right, so let's see. I have got this guy pretty much tore out now.
What?
These printers are such a pain in the butt. And my job would be so much easier if I worked at a hospital that supported buying stuff from eBay. Because you can buy all sorts of old stuff from eBay And you can, yeah, see? Yeah, somebody had to solder that on by hand. How goofy is that, huh? All right. So I'm going to pull the print head off, which means there's just a tiny little thing right here that we lift up. Come on. This is where things always bop you in the eye, huh? Come on. There we go. Okay. So that has to come off. And then this guy here will come off. Right? There we go. Okay. So we pull the motor.
I didn't have an eye because that can get up in my eye.
Okay. There we go. So what's this called?
Motivated.
This is called the circuit board. Okay.
Circuit board.
That's right. That's right. This is the circuit board or the controller board. So there is a fuse on it. So if you have one of these that has a power problem, you can change out the fuse.
Hey.
Yeah. Yeah.
Hey.
Ah, yes.
Yeah.
So it's got an integrated power supply, just like those massive power supplies that we had. You know, you got your power that comes in, goes through the fuse with the mains. You have your filtering components, and right here is a miniature bridge rectifier, and it goes from here, high voltage DC, into your chopper, and from there it's going to go into a transformer and rectification, smoothing, and to DC to power this guy up. So this guy, if it was a power problem, I think I could, you know, maybe resolve it. I had to fix a GE EKG today. I had a capacitor that was cracked in half right on the main board, and it's a $2,500 board if I remember correctly. And I used an old board as a donor, and I desoldered it, and I soldered it on this one without my hot air station. I used I had a video on the Milwaukee 12 volt, you know, the giant soldering iron, and I used that one to desolder a surface mount capacitor and then solder on this other board, and that was an absolute bear. Okay, so yeah, this guy right here, there's no saving it. It's dead. But so it does have serial communications, your serial controller, and then it goes right into your print controller. But nothing really special. The print head, let me pop this guy out. Let's see, where's my Phillips screwdriver? Do this guy. The print head on this guy is really generic. Hey guys, why don't you go in the house?
Daddy's trying to unlock your things.
Yeah. What if I don't want them locked?
Daddy tried to do like this.
Perfect. So here's the thermal print head, guys. There is a latch lever that I disconnected, and the latch lever just simply lifts up on this guy right here, which is the print head, actually. Let me just pull it off so you guys can see it. I want to get sprung on this guy. There's so much tension on it. Come on. There we go. It just rocks out. Okay, so you can see where the ribbon cable connects straight to your print head, and this line right here is your print head. Okay, and it just sends out little hot spots, and those hot spots interact with the paper, and that's what creates your lines. So it's really bare, man. This technology has been the same since what, the 90s, and here we are, you know, still using it. But you can still, you know, you can change out components like this between printers. So if I had one of the newer ones that's USB instead of serial, there's a very good chance that this print head's the same, and you just change them out. You know, if I have a problem with my print. This one's got a problem with its CPU. You can tell right here, it's just not registering. So anyway, that is it, guys. I have some other cool stuff, but I don't think I'm going to be able to take them apart today because apparently Daddy is not getting the hint, right? Right, guys? Yeah. Yeah. See, I'm not taking the hint on the fact that it's close to their bedtime, and I gotta go take care of them. So, guys, thank you for participating in this live stream. I have some other stuff. I because I took that giant light head controller, I couldn't bring this other stuff with me. But tomorrow, I might start bringing some other stuff home for the weekend because I'm hoping to do an even better teardown this weekend. All right?
Yeah.
Okay. You got some stuff on your face. Okay.
Hey.
Are you gonna tell everybody goodbye?
Bye.
Where's the other one? Creature 2. Creature 2. Where are you?
Behind you.
Okay, where are you? Hey, Addie. Addie.
3, 2, 2, behind
Are you gonna say goodbye?
Goodbye.
She doesn't care. 3-year-olds.
Bye.
All right, Bjorn. Life Delights. Mr. Steve Espiner.
What?
I will see you all later. All right.
Yeah.
Good night.
Bye.
Bye.
Bye. Yeah.